These are solutions to Calc 2, Exam 5. And number 1, A1 is 2, A sub n plus 1 is 3an minus 2. You basically triple and then subtract 2. So start with 2, triple and subtract 2, you have 4, triple and subtract 2, 10, triple and subtract 2, 28, triple and subtract 2, 82. Number 2, 0.08333 repeating. This is 8 over 10. This is 0.03, 0.003, and so on. So the sum is 4/5 plus S1, the infinite geometric series part. S1 is 0.03, A over 1 minus R of 0.1, 0.03 over 0.9, moving decimal over 2, moving decimal over 2, 3.0 over 90, 1 over 30. So the sum is 4/5 plus 1/30th, common denominator is 30, so 25 over 30, 5 over 6. Number 3, integral from 1 to infinity of 1 over x to the 2/3 dx. That's the limit as b approaches infinity of the integral from 1 to b of x to the negative 2/3 dx. Limit as b approaches infinity, 3x to the 1/3 from 1 to b. Take out the 3. X to the 1/3 means cube root. So 3 times the limit b approaches infinity of the cube root of x from 1 to b. So plug in b, you have cube root of b. Plug in 1, you have 1. So as b gets big, this gets big, subtract 1, it's big, multiply by 3, it's big, so it diverges. Since the integral diverges, the series also diverges by the integral test. Number 4, we know that n is greater than ln n, so by the reciprocal rule, 1 over n is less than 1 over ln n. Summation of 1 over n diverges, it's the harmonic series. Therefore, anything bigger than that would also diverge. Summation 1 over ln n also diverges by the comparison test. Number 5, the series is alternating. Absolute value of a sub n is decreasing. A sub n is 0, approaches 0. So the series converges by the alternating series test. You could also say it's a geometric series where r is equal to -1/2. Absolute value of r is less than 1. Number 6, the series converges. It's alternating. Terms decrease in absolute value and approach 0. But if I take the absolute value of all the terms, which means make the -1 stuff just 1, so summation of absolute value of a sub n is summation 1 over radical n, which is summation 1 over n to the half. That's a divergent p series where p is a half and p is less than 1. So therefore, the series conditionally converges. 7, ratio tests, absolute value of a sub n plus 1 over a sub n. So 3 to the n plus 1, x plus 1 to the n plus 1 over cube root of n plus 1 times the original flip. And put these two together, you have the cube root of n over n plus 1. 3 to the n plus 1 divided by 3 to the n is 3. And that divided by that is x plus 1. And that approaches absolute value of 3 times x plus 1 as n approaches infinity. So when will this converge? Well, when this is between -1 and 1, divide them all by 3. -1/3 less than x plus 1 less than 1/3. Subtract 1. -4/3 less than x less than 2/3. So my radius of convergence is 1/3. We're centered at -1. We already knew that ahead of time. All right, so at the beginning, we have absolute convergence between -4/3 and -2/3. Divergence here and here. And the two endpoints, we're not sure. So plug in -4/3. That gives a summation of 3 to the n, -1/3 to the n over cube root of n. That's -1 to the n over n to the 1/3. That converges, alternating. Absolute value of a sub n decreasing and a sub n approaches 0. Therefore, the series converges by the alternating series test. So color that in. X equals -2/3. That gives me summation 3 to the n, 1/3 to the n over cube root of n. That's the same as 1 over n to the 1/3. That's a divergent p series where p is 1/3 less than 1. So this stays open. So radius of convergence is 1/3. Interval of convergence is bracket -4/3, -2/3 parenthesis. Number 8 is integral from 0 to 0.2 of 1 over 1 minus a negative x to the 4th dx. Common ratio is negative x to the 4th. First term is 1. So 1 minus x to the 4th plus x to the 8th minus x to the 12th dx. So integrate. X minus x to the 5th over 5 plus x to the 9th over 9 minus x to the 13th over 13 plus ... Plug in 0, you get 0. Plug in 0.2. This should be 0.2. Let's see. Yeah, 0.2 minus 0. minus 0.2 to the 5th over 5 plus 0.2 to the 9th over 9th. Okay, this is 6 times 10 to the negative 8. So I can just add the first two, which is 0.2 and 0.2 to the 5th over 5. And that comes out to be 0.19994. Sorry, this should be this. Okay, 1 minus cosine 3x, 1 minus 3x to the 0 over 0 factorial, minus 3x squared over 2 factorial, plus 3x to the 4th over 4 factorial, minus 3x to the 6 over 6 factorial, plus 3x to the 8th over 8 factorial. I need 5 terms because I see I'm going to lose the 1 here. So that drops out all of these change sign. 9x squared over 2, 81 over 24, x to the 4th, minus 729 over 720. That should be a 720. 729, 6 factorial is 720, right? Minus 3 x to the 8th over 8 factorial. So 3 to the 8th over 8 factorial. So 9 halves x squared plus 27 over 8 x to the 4th plus 243 over 240 x to the 6th minus 729 over 2240 x to the 8th plus dot, dot, dot. Number 10, f of x is sine x. They want T3, third degree. So I need 3 derivatives. That's easy. Cosine, negative cosine. Plug in pi over 6, 1/2, radical 3 over 2, negative half, negative radical 3 over 2. So before we even start, x minus pi over 6 to the 0 over 0 factorial, x minus pi over 6 over 1 to the 1 factorial, squared over 2 factorial, 3 over 3 factorial, plug in 1/2, radical 3 over 2, negative half, negative radical 3 over 2. So final answer, 1/2 plus radical 3 over 2, x minus pi over 6, minus 1/4, x minus pi over 6 squared, minus radical 3 over 12, x minus pi over 6 cubed. Okay, so these are solutions to exam 5 of Calc 2.